Hi, welcome to Getting Converted, the third in a three-part series of introductory videos for Ms. Moser's chemistry class at Beaver Local High School. As with the other two videos, there is a short quiz that follows, and you'll probably want to get paper and pencil, and since we'll be doing some examples, you may also want a calculator for this one. Okay, let's get started. As you know by now, in chemistry and in all the other sciences, we use what's called the SI system of measurement. However, there's another term you may have heard, the metric system. So, are these two things equal? Are they the same? How are they related? Let's clarify this first. The metric system is any system of measurement that is based on some metric of 10. So, we include in this liters, grams, meters, all of these things. These are all metric measurements. So, what about the SI system? The SI system is a subset of the metric system and refers only to the 7 base units that are used in science and the derived units that can be made by various combinations of them. SI units include meters, kilograms, Kelvin, and moles. Note that grams and liters are metric, but not SI. Let's find a few others that are metric, but not SI. The other big one that's metric, but not SI, is degrees Celsius. Now, that said, in the science classroom, we do often find ourselves using liters, degrees Celsius, and grams. And that's fine. We just need to know that while they're metric, and they're convertible into SI units, they're not actually SI. Clear? Okay. Why all the fuss about converting? Well, in science, and especially in chemistry, we very often use numbers that are very, very large or very, very small. They get much larger and smaller than this, but these are a couple examples. And while we do make heavy use of scientific notation, the other thing that makes these numbers easier to work with is conversions and prefixes. In the entire metric system, including the SI system, all units can be modified by the use of prefixes. So 1,500 grams becomes 1.5 kilograms, and 0.0015 grams becomes 1.5 milligrams. Much easier to work with. Okay, let's take a quick look at the prefix system. Prefixes come before the base unit and they modify it, and each prefix has a specific meaning. In this video, and before the first day of school, you're only going to need to know 4 prefixes. We'll add more to the list once we really get going after school starts. These are the 4 prefixes that you'll be responsible for: mega, kilo, centi, and milli. Now, mega, as you might imagine, means large, and it's given by the abbreviation capital M. That capital is really important. Mega means 1 million of something, and its exponential factor is 10 to the 6th. Okay, let's look at kilo. Kilo is represented by the abbreviation lowercase k, and kilo means 1,000 of something. So its exponential factor is 10 to the 3rd. Okay, let's talk about centi and milli, our little guys. Centi is represented by the abbreviation lowercase c, and it means 1/100th of something. So its exponential factor is 10 to the -2nd. All right, milli, the smallest of the prefixes we're going to talk about today. Milli is represented by the abbreviation lowercase m, and it means 1/1000th of something. So its exponential factor is 10 to the -3rd. Don't get your capital M and your lowercase m mixed up. They're very, very, very different prefixes. Okay, why did I leave this big blank here? let's talk about base units. The term base unit has two different meanings depending on what we're talking about. So first, let's talk about it in the context of the SI system. When we say base unit in the SI system, what we mean is that it's one of the official 7 units that form the basis of the SI system. The 4 we use most often in chemistry are meters, kilograms, moles, and Kelvin, or those units modified by a prefix. In the metric system, however, when we say base unit, we mean a metric unit with no prefix. So that could be a gram, a liter, a mole, a meter, etc. Notice that some things are base units in both SI and metric. Don't worry, you'll be fine. It doesn't get much more confusing than that, I promise. So now, let's go back to this chart and why I left this big gap in the middle of it. This gap represents our base units, so we'll write them in. Meter, liter, and gram are good stand-ins for lots of metric base units, and the etc. is a reminder that there are many, many, many more metric base units than that, and we can modify any of them with our prefix system. But all the examples that we're going to practice today will use either meters, liters, or grams. We'll get to more metric base units when school starts. Before we get busy with our conversions, let's do a very quick review of simple multiplication and division using scientific notation and using exponents. So the first example we have is division, and we have 1.0 times 10 to the 5th divided by 1.0 times 10 to the 2nd. When we do a problem like that, we take the part that's in front of the scientific notation, the ones here, and we do the division on it. Well, 1 divided by 1 is 1. Then we take the whole thing and do times 10 to the, and when we're dividing, those exponents get subtracted. So this would end up being 1.0 times 10 to the 3rd, okay? Because it's 1 divided by 1 times 10 to the 5 minus 2. That's our final answer. Let's look at the next example. Here, we're multiplying two numbers that are in scientific notation. So, we again take the part that's out in front, do our multiplication, 1 times 1, I tried to keep it easy here, and multiply the entire answer that we get by 10 to the 3 plus 1. When we're multiplying two numbers that are in scientific notation, we add their exponents. So, 1.0 times 10 to the 4th would be our final answer for that problem. You'll get more practice as we go, so if this skill feels a little bit rusty to you, don't panic just yet. The format that we'll be using for all of our metric conversions, and for lots of other things in chemistry, is called factor label. You've probably done it before. It's sometimes also called unit analysis. You'll see why in a little bit. It's a fantastic problem-solving tool, and it's one that can ensure you success in chemistry if you make it your friend early on. So, there are a couple simple rules for using factor label to do conversions. Okay, here's our first problem. We have 3 kilograms, 3.0 kilograms, and we'd like to know how many milligrams that makes. Let's use our factor label, and we'll examine our simple rules for solving with factor label. The first rule, always put your given in the first box. That's pretty simple. No matter what your given is, it's going to go here. Okay, our second rule, when you look at the box on a diagonal from your first box, the units there have to match the units in your first box. So the units that we're going to put down on the bottom are kilograms. This allows us to cancel our units as we go, and that's what we need. The third rule is that whenever we're doing a conversion, whether we're starting with something very large and going to something very small, or just moving from one small unit to another, whatever we're doing, we're always going to have a base unit in every single set of boxes. So, since we're in kilograms and we're going to milligrams, the metric base unit that we're using here is the gram. Each of your boxes will have a unit with a prefix and a base unit. If we filled in values right now for grams and kilograms and multiplied out, we would convert kilograms to grams. But that's not the unit we want to end up in. So we have to keep going and do one more set of boxes. Now, if we look at rule number 2, the units must match on the diagonal to cancel. This applies to all of your sets of boxes. So, the units that are going to go down here are grams again. Now, okay, the next thing we need to make sure of is that the last set of boxes that we're working with on the top has the units that we want to end up in. So we want to end up in milligrams. This box should have the units milligrams. Let's check our rules so far. We have rule number 1, our givens in the first box. Check. In each case, our units match on the diagonal, so they'll cancel. Each set of boxes has a base unit. Here are our grams. And our fourth rule, our last box has the units on top that we want to end up in. Okay, so far so good. Now we need to fill in some numbers so that we can actually come up with an answer. This is where we have to refer back to our exponential factors. So, if you recall from a couple slides ago, the exponential factor for kilogram is 10 to the, for the prefix kilo, is 10 to the third. And the exponential factor for the prefix milli is 10 to the negative third. Okay, you've probably done these kind of conversions using the numbers 1,000, 100, but in chemistry we will always do these using the exponential factors. You're going to have to get used to it. Don't panic, we'll get you through. So, our fifth rule, the exponential factor always goes with the base unit. This is how it's going to look. So, 1 times 10 to the third grams is equal to 1 kilogram. If you were doing that using the number 1,000, it would be a true statement to say that 1,000 grams equals 1 kilogram. In the last box, we say that 1 milligram is 1 times 10 to the negative third grams. So, that's our fifth rule. The exponential factor always goes with the base unit. Okay, so now that we've got all of our numbers and all of our units set up, let's check ourselves to make sure our setup's correct. And we're going to do that by canceling our units. If we look at our units, kilograms cancel kilograms, grams cancel grams, and we're left with milligrams. And that's the units we're looking for. So our setup is correct as long as we put our exponential factors with the base and we have the correct exponents. We can't go wrong from here. Okay, we've taken the whole numbers. In the case of the things that have exponents, it's what's out in front of the exponent, and we've placed it into a multiplication and division problem. So we take 3 times 1 times 1 divided by 1 times 1. Now we have to work out our exponents. So that whole mess times 10 to the 3 minus a negative 3. Well, that's 3 plus 3. So what's our final answer? 3.0 times 10 to the 6th milligrams. So 3 kilograms equals 3.0 times 10 to the 6th milligrams. Let's try a couple more examples. Okay, we've got our next problem. 5.0 megagrams equals how many centigrams? Let's start by checking through our rules. We want to put our given in the first box. Okay, so far so good. Now, the units have to match on the diagonal to cancel. So when we look at our second box, the units on the bottom have to be, that's right, megagrams. And each set of boxes has to have a base unit. Since we're going from megagrams to centigrams, the base unit, the metric base unit, is once again grams. Referring back to Rule 2, units have to match on the diagonal so that you can cancel them. So we know grams will be down here, and the last box has to have the units on top that you want to end up in. So that'll be centigrams. Okay, now we'll go ahead and put in our exponential factors. If you recall, the prefix mega corresponds to the exponential value 10 to the 6th, and the prefix centi corresponds to the exponential value 10 to the negative 2nd. Now the trick is, where does that exponential factor go? Well, look at Rule 5. The exponential factor always goes with the metric base unit. How will that look? Like this. 1 times 10 to the 6th grams equals 1 megagram. And 1 centigram equals 1 times 10 to the negative 2nd grams. Okay, now let's check our units and cancel. Okay, megagrams cancels megagrams, grams cancels grams, and we're left with centigrams, which is just what we wanted. Now, let's do the math. Okay, here's what the math will look like. We've taken 5 times 1 times 1 divided by 1 times 1, and that whole mess is times 10 to the 6th minus negative 2. Well, we know that that's 6 plus 2. So our final answer is 5.0 times 10 to the 8th centigrams. So 5 megagrams equals 5.0 times 10 to the 8th centigrams. Let's look at a couple of logic checks. Both problems that we've just done involved going from a very large unit, 1,000,000 grams, down to a very small unit, 1/100th of a gram. And in both cases, our answer was a very large number. If you are going from 3 miles and you're going down to inches, the number of inches you have is going to be very, very large, because inches are a much smaller unit than miles. Same thing applies. When you're going from a very large unit to a very small unit, you're going to have a very large answer. Okay, let's do one more example together, and you're off to take your quiz. All right, so here we're going from 2 milligrams, a very small unit, up to kilograms. What do we think our answer is going to look like? It's probably going to be a very tiny number. If you had 2 inches and wanted to know how many miles that was, you would expect to get a very tiny decimal number. Okay, let's start walking through our rules and walking through our factor label to see what kind of answer we get. Of course, according to Rule 1, we've got to have our given in our first box. So, our first box starts with 2.0 milligrams. Now, units have to match on the diagonal to cancel, so the next box on the bottom will have milligrams. Each set of boxes has to have a base unit, so we'll put the base unit above. And again, back to Rule 2, we're going to have grams on the bottom in that last set of boxes. The final box has to have the units on top we want to end up in. So, kilograms it is. Alright, now that we've got our units in place, let's put in our values. Remember that the exponential factor for milligrams, or rather for the prefix milli, is 1 times 10 to the negative 3rd. And the exponential factor for the prefix kilo is 1 times 10 to the 3rd. So, let's put in our values. Remember that the exponential factor always goes with the base. So we've got all of our values in. Let's check our units to make sure they cancel. And sure enough, milligrams cancels milligrams, grams cancels grams, and we're left with kilograms, which is what we'd like our answer to be in. Now let's do the math. Here's our preliminary step. We've taken our 2 times 1 times 1, divided that by 1 times 1, and now we've put it to a power of 10 to the negative 3rd minus 3. So, what's our final answer? If you said 2.0 times 10 to the negative 6 kilograms, you'd be correct. And as we said, we expected this to be a very tiny number, which it is. All right. When you go to back to the PB Works Chem Daily page, you'll find a link to the quiz. I think you'll be able to do it quite easily, and we'll work a lot more with metric conversions once we start school. Remember, by the first day, you're responsible for the material in this video, which means you are responsible for knowing the 4 metric prefixes that were discussed in this video: mega, kilo, centi, and milli. Take your quiz, this is it, and I'll see you on the first day of school.